Hello Year 7, it's Miss Redmond here again with another summary PowerPoint from the particles topic. This one is called What is Boiling, and you can see the learning journey at the bottom there. You can pause the video and write down those points if you like. Your do now task is what happens to the water when you boil a kettle and where does it go? So please can you pause the PowerPoint now and write down your ideas. We'll get the right answer on the next slide. So when you boil a kettle, the water heats up and it turns into steam, which is a gas. The steam doesn't disappear from existence, it's still there, but it's in the air and it spreads out around the room. So for that reason, scientists say that mass is conserved when you boil water. You've got those key words there in bold. So that means that the substance, the actual water particles, haven't disappeared from existence. They're conserved, they still exist when you boil water. You're not changing the particles, you're just changing the state. So it's gone from a liquid state to a gas state. Okay, here is a video of boiling water. It is more interesting than it sounds and it's very artistic and it's really useful because it's showing you that when you boil something, when you boil a liquid rather, bubbles of a gas form throughout the liquid, which is different to evaporation, and that's going to be important in our next lesson. Alright, so here we have on the left a diagram showing boiling. So we've got the liquid particles labelled and you can see they're close together, they're all touching each other and they're moving all the time, which you obviously can't see from the diagram, but we know that from our previous lessons. So the liquid particles are moving around all the time, but when they get heated up, they start to move faster. And because they're moving faster, they start to take up a little bit more room. Now eventually they move so fast that they can break away from each other, they're no longer touching and they're taking up more space, and they've actually formed a bubble of a gas, and you can see 3 gas bubbles on that diagram. So this happens throughout the liquid during boiling. Bubbles of a gas form and those bubbles rise to the surface of the liquid and eventually they can escape, which you saw in the video and you will have seen if you've boiled a pan of water or if you've got a kettle with clear walls, or if you've maybe done a practical in science where you've heated water and you can see the bubbles moving through it. So have a look at those sentences on the right hand side and see if you can complete those sentences. Pause the video while you do that because you're going to see the answers on the next slide. Okay, here are the answers. So in a liquid the particles are close together and moving. When the liquid is heated the particles gain energy. Then they start to move faster. Eventually they can move away from each other, bubbles of a gas form throughout the liquid and the bubbles start to rise to the surface and escape. Alright, so you can measure the boiling point of a liquid in the lab and you can do it using this equipment. There is actually something missing from here, so if you've done any practicals you might be able to tell me what's missing. You can pause the video while you have a look if you want to. So there should be a heat-proof mat underneath the Bunsen burner and the tripod stand to protect the desk or whatever you're working on, which will be a desk. Okay, anyway, you've got a Bunsen burner in the middle at the bottom. That's going to heat up the water. And the water is in a beaker. That's like a glass cup. That's what we use to do most of our experiments involving liquids in the lab. You've got the beaker sitting on a wire gauze on top of a tripod, so that's there to hold the beaker up over the Bunsen burner so you can heat it safely. And in the water is a thermometer. So in this experiment, you would set up the equipment as it's shown, and then you would heat it and heat the water and measure the temperature every minute. Take your results down in a table and draw a graph, and the next slide is going to show you what the graph looks like. Here is a graph to show the boiling point. So you can see at time 0 the temperature of the water was 20 degrees. That's what temperature tap water usually comes out at. And the red line and the blue crosses are showing you that the water is heating up. So you can see that the second cross is at 50 degrees. So in 1 minute, the water's gone from 20 degrees to 50 degrees. Then it's gone to 70. Then at minute 3 and 4, it looks like we've got some dodgy results in there because they're not following the pattern. So we call those anomalies. And then by minute 5, the water has reached 100 degrees centigrade. So you might already know that that is the boiling point of water. And this graph is actually showing you the kind of results you would get if you boiled water. So at 100 degrees, the temperature then stays the same, because instead of the energy making the particles move faster, the energy is actually being used by the particles escaping from the liquid. So the temperature of the water won't get above 100 degrees C at normal pressure. So that's how you can tell the boiling point of a substance, and that can be very useful. Here's an extension task for you. Have a look at the purple box. It says mystery liquid. Sarah has a liquid, and it could be water, ethanol, or propanol. Presumably she's in the lab and the labels have come off the bottles, so she doesn't know which one she's got. Sarah heats the liquid and it bubbles vigorously, that means it bubbles a lot, at 97 degrees C. Use data from this page to suggest what the liquid might be. So you've got a table at the bottom with an orange header that says that water has a boiling point of 100, ethanol has a boiling point of 78, and propanol has a boiling point of 97. So pause the video now and write down what liquid you think Sarah has. Okay, so Sarah's got propanol because she's observed it bubbling. She's observed it boiling at 97 degrees C. So out of those 3 liquids, it must be propanol. So you've got a little extension which says what is Sarah's mystery liquid and how might she have done the experiment. So if you want to do this bit, pause the PowerPoint now and write down a method for how Sarah could have done that experiment, and you can check if you got it right by going back through the PowerPoint and listening to my explanation of the boiling point experiment. Alright, so you can use melting point and boiling point to predict the state of a substance at different temperatures. So this is your task for this slide, is to use the temperature scale to predict the state of silver at different temperatures. So what is the state of silver at 700 degrees C, 1100 degrees C, 1650 degrees C, 2300 degrees C? So if you think you can do that already, pause the PowerPoint now and write down your answers. If you don't think you can do it already, keep listening. So if you look at the left hand arrow that says the melting point of silver is 961 degrees C. So if you think that melting is a change of state from solid to liquid, Any temperature lower than that, the silver is going to be a solid. So all the temperatures to the left of that arrow, the silver will be solid. Sorry, I confused myself with left and right there. Okay, so that means that all the temperatures to the right of that arrow, up to the next arrow, the silver is going to be in the liquid state. Now we've reached the right hand arrow says the boiling point of silver, and you now know that the boiling point of a substance is the temperature that it turns from a liquid to a gas. So any temperatures to the right of that arrow are the silver is going to be in the gas state. It's also going to be extremely hot because you can see the boiling point of silver is 2210 degrees C. Okay, so if you weren't sure before, go back and look at those temperatures and predict what state the silver is in at each of those temperatures. Pause the PowerPoint now and have a go, because the next slide is the answers. All right, they've all come up at once. I wasn't expecting that. So at 700 degrees C, the silver is solid. At 1100, it is a liquid. At 1650, it's still a liquid. And at 2300 degrees C, it is a gas. If you're not sure about why that is, go back to the previous slide and listen to the explanation again. Okay, here's your summary slide. These are the key points that you need to remember. Mass is conserved during boiling. The temperature at which a substance boils is called its boiling point. You can measure the boiling point of a substance by heating it, measuring the temperature every minute and drawing a graph of the results. The boiling point will be shown by a flat horizontal line on the graph. You can use the boiling point to identify unknown substances, and you can predict the state of a substance if you know its melting and boiling points. Feel free to pause the PowerPoint now and write down those key points if you like, and I will speak to you next time.